Hi everyone. So today we're going to expand even more on the notion of variables by diving deeper into variable types. So I'm going to hide my face, go to open, new file, open folder. We're going to create a folder called types. Select it. Go to terminal, new terminal, .NET new console. Those who are joining us for the first time, guys, will be very beneficial that you follow the tutorial from lesson 1, where I instruct you how to install Visual Studio Code, which we're using at this moment, and all the lessons up before that lead to this point. So we click on program.cs, gives us the hello world application, which we're going to delete. I am prompted to use debugging. I say yes. So before I go into types, I want to touch about something called conversions, right? So when I create my bucket of type integer called x and set it to, let's say 1, 2, 3, 4, 5, 6, 7, 8, right? So I created a bucket of type integer called x. Inside I placed 1, 2, 3, 4, 5, 6, 7, 8 value, right? Then I go in and create another bucket of a smaller size. So when you look at the types, integer spans from this range, and short spans from minus 32,768 to 32,767. So let's use short. Let's put those ranges in there. So short s equal to 20. So short span to this, right? So we have these two, right? So let's say, okay, I want to take the contents of s and put it into x, right? So I go x equals to s, right? Putting value of s into bucket x, right? I can do this, right? Because I'm going from small to large. Both types, int and short, are a type of are numeric, right? But what happens if I want to go the other way around, right? So I take s and I put it in, and I try to get what's in x, right? So it doesn't like it, right? It tells me cannot implicitly convert type into short. So here I was able to do this, but here I can't, right? So this first one is an example of implicit conversion. The second one, it doesn't allow it, right? So let's disable this, right? Let's try this again. S equal x, right? So you think I'm thinking to myself, so if I write it a second time, the computer would say, okay, since you really want this, I'm gonna allow it. No, it doesn't. Can't do it. So it doesn't allow me to implicitly do this, but I can say to the computer, listen, I really want to do this, and I know that X will be small enough that I can fit it into S. So what you can do is you can open parentheses, you can type what you want to convert it to. So you want to convert it to short, and you close the parentheses and you put it in front of the bucket name. So putting value of X into bucket as example of explicit conversion. So little word on the explicit conversions. You got to be careful with them because you have to really know that what you're doing is gonna work. So let me give you an example. So let's say I restore the value of X to what was there originally, right? Now I will do explicit conversion of X into S, right? So, okay. So what do you think is gonna happen, right? You think it's gonna be falling within the range of 32768? Will the computer reject it, accept it? What's it gonna be, right? So let's try it out. Console write line. Let's say content of S after explicit conversion from X, right? So what's it gonna be? This is like an example of exploring, right? When you're curious in something, you're writing your own program. Sometimes it's good to check because you know you learn through experience. So let's save this, save all, and let's run it. So you see we got some garbage value, right? 24,910. So there's a danger over here. If you're not sure what will be the value of X. So just keep that in mind whenever you do explicit conversion. The computer initially stops you, which is correct. But if you override that rule, you overrule. It's what I want, my way or highway, right? There's a danger that things can go haywire. All right. So these values, right? They're foreign those types, right? What do they? What's happening with those types? What's so special about them, right? So there are three sorts of types, right? We have value types, which we've been looking at a lot. So value type is basically this content of a value type is just the value, right? So when I have int x and I set it to 5, right? So value type of x is 5, right? Oh, x has been used, so let's do x2, right? You would say, wow, Captain Obvious, what else could it be, right? So let's just go through an example and then you guys will know what I'm talking about, right? So these are value types, right? So there's a value type called struct, right? Structs are similar to classes that they're defined like this. You go public, struct, let's call it coordinates, right? And then inside, as we know, coordinate have an x coordinate and a y coordinate, right? So we will have public integer, right? And then we will have x coordinate and y coordinate, right? So let's call this struct value color value coordinates, right? So it will be easier to demonstrate later, right? So we go like we would expect, like value coordinate. We would say value coordinates, name of the variable, equals new value coordinates, right? And then you will go and you will say value coordinates x. Let's set it to 8. And then you have, let's do the y value. You will set it to, let's say, 6 or 5. Doesn't matter, right? Good so far? So now we're gonna create another set of coordinates. We're gonna say value coordinates 2, and we're gonna set them to the original value coordinates, right? So value coordinates 2 gets a copy of value coordinates and set equal to that, right? So let's test this out, right? So console write line. Let's do this trick where we can actually utilize positioning. So you do string convert. Doesn't let me. String. Ooh. Oh. Okay, convert to string. Okay, so it's convert to string. Sorry. So we type in value coordinates. So it will be x position 1, and then we do y position 2. And then we will just put the coordinates here, copy and paste them. So this doesn't like it either, right? Oh, string format. That's the one. Okay. You see, sometimes you get stuck and you know something and you keep playing around till you eventually get it. So string format allows you to do placeholder replacements. So you, as I mentioned this in one of the lessons, so you specify the order with the curly brackets. So the first order, the second order, and then you have them listed here: first order, second order, and it starts at 0. 0 is the first one, and then second one is 1, right? So what this will do is we'll replace this guy with this guy, right? So we have value coordinates for this one, and then let's do value coordinates by copy and pasting for the second one, right? So value coordinates 2, and then we go like this, right? Let's save this and let's run this. Save all. So we have what we put in. We have the value of for x, we have 8, for y is 5. Then the copy is 8, 5, right? So I'm going to change now. I'm going to change the first one and see what happens. So I go back to value coordinates and I change x. I would say, let's say 10, and y I will make 11, right? And let's write this again, right? So let's see what happens now. Save all. Okay, so the first set, obviously nothing happened because we're changing values after the fact. And then you see the first set of coordinates, it took this change 10 and 11, which we see it here. And the second set, nothing happened, right? So this is the generic behavior of value types. You put in a value, it gets that value, and there it is, right? But then we have also a type that's called a reference type, right? So then we have also a reference type. The reference types, they're different because you are now not only dealing, you're not dealing with a value, we are dealing with an object and a reference to that object. Okay. So let's look at this example, right? So we have a struct value coordinates, right? Now we do a class-based coordinates, right? So we do public class. Let's call this class coordinates. We're gonna have a public int x get set, right? Then we have public int y get set, right? So here we go, right? Gonna be a little similar, but you guys gonna be so surprised after you see something. So we go class coordinates. Class coordinates is the name of the variable. Equals new class coordinates. Oh, wrong one. And then we're gonna set our class coordinates. X equals to, let's follow the same assignments. Right? So 8 and 5. Then we're going to do this again and create another set. So class coordinates, misspell something. Class coordinates 2 equal new class coordinates. No, now I'm not gonna do new. I'm gonna assign it to the first class, right? So class coordinates equal class coordinates, right? Now let's write out the screen. So console write line string format. So you would type some informative stuff. So you say class coordinates x, same idea as before. Now we're going to put what we're going to actually use. So copy and paste class coordinates x, comma, copy class coordinates y. And these replacements can go infinite, right? You can go from 0 to as many as you like. So then you will have just comma, 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 as many as you need, right? So this is the first one. So now I'm going to just copy and paste and make little replacements. X. All right, so let's save this. Save all. Let's run it. Okay, so it's behaving the same way as struct, right? Seem like you were saying you're wasting our time, man. It's doing exactly the same thing. So it looks like reference type and value types are the same. Okay, so let's try let's go to the original ones, copy and paste it, and we're gonna change the original, right? So we're gonna set them to 10 and 11, right? Now let's write down the values again. Okay, save all. Let's run this. So we're going here and we're saying, dude, you only update the first set of coordinates. Why did the second set of coordinates also get updated? It's supposed to be 8, 5, not 10, 11. So you see, that's the difference of a reference type, right? Over here, when I say coordinates class coordinates 2 equals class coordinates, I'm basically making coordinates class coordinates 2 behave the same way as class coordinates. It's like a copycat at all times. Because it's let's say, how can I show this? So everything origin. Let's put something like this, right? So let's. I'm not gonna use X and Y because I use this. So C1 and C2 coordinates 1, coordinates 2, right? So everything is pointing to this origin, right? So when origin changes, everything changes across all the ones that point to origin, right? So this guy does not work well unless you really want to do it this way, but I don't see a reason why would you want to do it. Right? So that's one very, very big difference. So that's the danger with reference types. So if you make a mistake here, one will always behave the same as other. So that's why this, when you do new class coordinates, you basically create another instance. Here you're basically pointing to the same thing, right? So that's a very big difference between the value types and reference types, right? Another thing, so I can take class coordinates and destroy it by setting it equal to null, right? So look what happens now, right? You see, it doesn't, it crashes because I set it equal to null. I'm trying to, null means it doesn't, it's there, but it doesn't do anything. It's sort of like disabled, right? So when I'm trying to write class coordinates to X, it doesn't know how to do it because it's set to null, right? So that's classes type, classes variables you can set to null, right? If we try to do this with a struct, so let's put comments here. If you want to do this with a struct, so struct coordinates how did I call this before? Or value coordinates, right? So value coordinates, let's say 2. Can I do this? Right. This is illegal, right? So the structs you cannot set to no. So you're saying to yourself, well, why we have reference type and why we have value types? Why not just have value types? What is this confusion? Well, the thing is that and there are implications in terms the way they're stored. So best way to illustrate this, right? When to use a struct and when to use a class, right? Structs are very simplistic structures, right? So if you really want to represent something very small, that's basic, that doesn't change often, and you don't convert it to an object, like so for example I have something like this, right? Int z equal 0, right? Then I have something like this, object o equals z, right? If I don't do this often, then structs are okay. But if not, you want to stay away from stacks, from trust. Trusts internally are stored on a stack in memory, and you can overblow that stack, right? If you keep dumping your data in there, right? So if your program is really big, you use structs, you can blow it up. And what you want to, so classes are used like 99% of the time. So you will want to use a reference type for that. They do take a little bit more storage space, but they are used more in every program, right? So stick with classes unless you're doing something very small, doesn't changes often, and you don't do this type of conversion. In my programming career, I can give you examples like I use structs maybe not even 10 times in all the years that I've been coding, so you don't use them really often. But here I did it just to illustrate difference between a value type and a reference type. And there's also strings are also reference type, but understanding what goes behind the scenes when a string gets created and set to value, it's outside the scope of this discussion. Okay, so I hope this illustrates you the difference between value type and reference type. There are also something called pointer types. I'm going to also touch later on, where you deal directly with spaces of memory. but that's labeled as unsafe programming. Because if you touch the wrong piece of memory, you can crash your computer. So this is very delicate type of work. So that's pointer types. So what we went over today, we went over about conversion, the implicit and explicit. We looked at value types and reference types, mainly struct and classes. And why would you want to stay away from value types, from structs? So thank you very much for watching. I hope this helps somebody. Please subscribe. All the best. Bye bye.